Hi everybody, this video goes over the application portion of section 2.2 in Math 116. And in the application portion you will have three problems. And here is our first problem. In this problem we have a retail chain that is selling bike helmets. It's not selling bike helmets, but it sells bike helmets. I think autocorrect got the better of me. And the retail price in dollars and the weekly demand is related by this particular equation. So this is our price-demand equation. And our first task is to describe how the graph of p of x is related to the graph of its elementary function f of x. Well, notice we are starting off with the square root of x. We are multiplying it by -4. The negative sign accounts for a reflection, so we have a reflection on the x-axis. The coefficient of the 4 is a vertical stretch by 4 units, and the positive 115 is a vertical shift. So we have a vertical shift or vertical translation of 115. So we just have to find the entry that actually has that. Okay, so let's take a look at A. The graph of p of x is the graph of f of x, which is vertically stretched. That is true, by 4. Okay, so that's good. It is shifted up by 115, but it says nothing about it being reflected across the x-axis, so this is off. Okay, now the graph of p of x is the graph of f of x, which is vertically shrunk by a factor of 4. That's not true. It's vertically stretched by a factor of 4, so this is wrong. And it is shifted up by 115, but once again doesn't say, and so since this is wrong and there's nothing about reflection, this is off. Now for C, we have that the graph of p of x is the graph of x, which is vertically reflected in the x-axis. Awesome. Vertically stretched by 4, yes, and shifted up by 115. So this right here would be the correct answer. And then finally, the graph of p of x is the graph of f of x, which is reflected in the x-axis, which is true, is vertically shrunk by 1/4, which is also a kind of a crazy way of saying that it's vertically stretched by 4. So that's kind of weird, but it is accurate. But it is not shifted down by 115, so this one can't be it either. Okay, so that takes care of part A. What about part B? Well, in part B, you actually have to select the graph. Now remember, we are vertically shifted by 115. So V shift 115. We are reflected across the x-axis, and we are stretched by 4. So basically our graph is going to be the regular square root of x, which is shifted up by 115 and then reflected across the x-axis. Now one really cool thing that we could do is evaluate the intercept. Unfortunately, this graph does not go all the way down to 0. It actually stops at 1. Or in this particular case, notice here we are actually at 10. So let's take a look at what this function would be equal to when x is equal to 10. Well, if x is equal to 10, we will have p evaluated 10 is going to be equal to 115 minus 4 times the square root of 10, which is about 102.3. So when x is equal to 10, we would have that y is equal to 102.3. And if we look over here, here is 10. 102.3 is right about there. This can't be the graph. The same thing with this one. And actually the same thing with this one. Now this one actually is pretty close to 102.3. But let's take a look at another point. How about p of 100? It's easier to compute the square root of 100. Well, that's going to be equal to 115 minus 4 times the square root of 100. Well, the square root of 100 is 10, so this is going to be 115 minus 40, which will be equal to 75. Okay, well here's 100. And there is 60. Each one of these is 4 divisions because basically we have 5 divisions in 20. So this is 64, this is 68, this is 72, that would be 76, or right about there is 75. So this one seems to work and the rest of them don't. And this 175 would be right about here, so it's not fitting. Once again, 75 would be there, and 75 would be way down there. So this is actually the only graph that works, and that's how you would do it. Basically find two easy points to compute and see if they plot. Now just the biggest thing here is to realize that we have 1, 2, 3, 4, 5 divisions covering $20. So each division is going to be $20 divided by 5, which is 4. So starting at 60, that's 64, that's 68, that's 72. That line up there would be 76, and that would be 80, so that's pretty close to 75. For your next problem, in this example, we are going to be dealing with electricity rates. And of course, the problems that you have are going to be contrived so they actually work out in a straightforward fashion. These right here are the actual rates that Duke Energy charges for us. And notice that we have a base charge of $11.96. Then for the first 1,000 kilowatt hours that we use, we are going to be charged $0.1053. And then once we go over that 1,000 kilowatt hour threshold, we'll be charged $0.1122. Or you could say for the first 1,000, we're charged 10.53 cents per hour, and then we're charged 11.22 cents per hour once we go over the $1,000 mark. And we need to come up with a piecewise definition for the monthly charge. Well, notice that this piecewise definition is going to have two components, or one for 1,000 or less, and the one for when it's over 1,000 kilowatt hours. Now, if it's less than 1,000 kilowatt hours, our equation is going to be, well, the base charge, which is $11.96, plus our rate here, which is 0.1053 times the number of kilowatt hours that we're using, or that we have consumed, which will be X. Now, if we go over 1,000 kilowatt hours, it's going to be equal to this amount at 1,000. So it's going to be, our cost is going to be 11.96 plus this plus 0.1053 times 1,000 plus 0.1122 for every hour over 1,000. We can write that as X minus 1,000. So that would be our equation, but we cannot write it in this form. We actually have to write it as a number times a slope times X. So we need to simplify this. And of course, the first thing we can do is, well, we can keep the 11.96. We can multiply the 0.1053 times 1,000, and that will be 105.3. Using the distributive law here, we will have, no, not negative, plus 0.1122x minus 112.2. Okay, now we have like terms. We have a like term here, here, and here. We can simplify that. And if we do, we will have 5.06 plus 0.1122x. And this right here is the second rule. And that's what we will put down here. 5.06 plus 0.1122x. So this is what w of x would be. This is our piecewise function. And now part B is to compute the graph. Okay, and here are our four options. And let me rewrite our equation again. We have that w of x is equal to 11.96 plus 0.1053x when x is less than or equal to 1,000 kilowatt hours. And then it's going to be equal to 5.06 plus 0.1122x when x is strictly greater than 1,000 kilowatt hours. Okay, so Notice here that our equation is going to have an x-intercept, and that x-intercept is not going to be 0. This graph has an x-intercept of 0. It can't be it. This graph has an x-intercept of 0. It can't be it. Also notice that the x-intercept is 11.96, and I was nice enough to produce the points for you, so you don't have to figure out the values, but you're not going to have that luxury in your homework. But nonetheless, notice that this x-intercept is way over, or this y-intercept is way over 50. This can't be the graph. This has to be the graph. Now, just to make sure, let's evaluate w when x is equal to 1,000. And what will you get? Well, you're going to get 11.96 plus 105.3. And yes, that will give you 117.26. And there you go. That's that particular point there. And if you evaluate at 1500, you would get that point. So this is indeed the correct graph. And this brings us to our last problem. And this is an example of state income tax. Now, of course, this is contrived because I believe that the state income tax charts for South Carolina have about 7 brackets. Here we only have 3. So here are the tables. This table is for those that are single or married and filed separately or head of household. This right here is for those people that are married and filing jointly. Typically, at least in the United States, for federal tax, this always gives you a tax advantage. But anyways, our question here is to write a piecewise definition for the tax due on the income X dollars for an individual, which means we want to use this table here, not this table. Now to do this, I'm going to move on over to OneNote because I simply don't have enough information. I don't have enough room here to do this. Okay, so here we are, and here are the tables again. Now once again we are going to be working with this particular table, this table right here, and notice that we have 1, 2, 3 brackets. That's going to correspond to 3 equations. Now, if it turns out that if you are making more than 0 and less than $15,000, your tax is going to be 3% of your taxable income. So that now we can't use percentages. We actually have to use the actual decimal. So to find the decimal, you would divide by 100, and you would have that your tax is going to be equal to the 0.03 times x, the amount of money you're making, if x is less than or equal to $15,000. We could put 0 greater than equal 0 is strictly greater than x, but we can't make any money, so we're just going to assume that the bottom line is 0. So that's that one. Okay, now the next table, and I'm going to write over here, says that if we are making more than $15,000, so if x is strictly greater than 15,000, but not over 30,000, that would be less than or equal to 30,000. Then we are going to pay $450 plus 5%, 5.8%, which would be 0.058, almost messed that up, times every dollar over $15,000, which we can write as x minus 15,000. Now, once again, we cannot write the equation like this. We actually have to write it as in a slope-intercept form, and that basically is a number, a basic number times the slope times x. So we need to simplify this. Using the distributive property, we will have, well, once again, just 450. Now, using distributive property, we will have 0.058x. And then 0.058 times a negative $15,000 is minus 870. And then combining these like terms, you will have negative 420 plus 0.058x, and that's what would go here. Minus 420 plus 0.058x, And of course, this will be valid when x is strictly greater than 15,000, but less than or equal to 30,000. Then finally, we have to deal with the case when x is strictly greater than 30,000. Not greater than equal to, but strictly greater than 30,000. Now, reading here, notice that we have to play if we made more than $30,000 in taxable income, we had to pay a flat rate of $1,320. Okay, plus 6.55%, and as a decimal, that will be 0.0655 times every dollar you make in excess of $30,000, which we can write as x minus 30,000. Okay, to simplify this, we can write down 1320. Using the distributive property here, we will have 0.0655x. 0.0655 times the negative 3,000 is going to be negative 1965. Combining like terms, we will have negative 645 plus 0.0655x, and that's what we put here. Negative 645 plus 0.0655x, and this will be valid when x is strictly greater than 30,000. And this is what you will put into MML. Now, I believe they have fields for each of these. For these terms right here, you just have to put these in, you'll be good to go. Okay, so that is part A. Let's go back to our PowerPoint slides and check out the rest of this. Okay, now for part B, we need to determine the graph of the tax. Now, let me go ahead and rewrite the equation. This t of x is going to be equal to 0.03x when x is strictly greater than 0 and less than or equal to 15,000. It's going to be equal to negative 420 plus 0.058x when x is strictly greater than 15,000 and then less than or equal to 30,000. And then finally, it's going to be equal to negative 645 plus 0.0655x when x is strictly greater than 30,000. Okay, well, notice that when x is equal to 0, or at least approaching 0, t is equal to 0. So basically, if x is 0, t is equal to 0. So one of our points on the graph is going to be the point 0, 0. It turns out the y-intercept would be 0. Here, the y-intercept is not 0. This cannot be the graph. Okay, what else can we do? Well, we can look at this when this is we can look at the tax rate when this is 15,000. If our income is $15,000, then our tax rate is going to be equal to 0.03 times 15,000, which, by the way, is $450. Which means we have one point, which is 15,000, $450. So let's come over here to 15,000. And notice here we have 1, 2, 3, 4, 5 divisions between 0 and 500. So basically each one of these divisions is 100. So once again, 15,000. Well, this one can't be it, so let's not even look at that one. 15,000, 100, 200, 300, 400. That's right in the middle. That looks about right. Over here we have, well, over here we're at $800, so that can't be right. So this has to be wrong. And let's go ahead and just look at this at 30,000. at the other point. And if we did, we would find that the tax is equal to $1,320. Okay, well, let's go to 30,000. Here is 1,000, 1,100, 1,200, 1,300. That looks about right. This one's not even close, so this actually has to be the graph. And now we have two more problems. The first one is find the tax due on an income of not that, but $23,822. Well, notice that, let's come back over here. Notice that the income of $23,822 puts us in this bracket right here. Okay, so we need to use this equation to solve it. Using that bracket, we will have the following equation: negative 420 plus 0.058 times, well, our salary, which is $23,822. And that will give us a result of $961.676, and that will round up to $961.68. Okay, and this brings us to the last part, which is, would it be better for a married couple in this state with two equal incomes to file jointly or separately? Well, to determine this one, let's suppose that each couple makes $30,000. Okay, so the husband makes $30,000 and the wife makes $30,000. If they file jointly, then each would pay the exact same tax. And the tax would be the same as this bracket right here, since we were in the $15,000 to $30,000 range. So each person would pay negative 420 plus 0.058 times $30,000. And that would give us a tax of $1,320 per person. So since there are two of them, the total tax if filed separately will be $2,640. Well, what if they file jointly? Well, then we'll add up the total. We will add up each income to get a total income of $60,000. And we now need to figure out how much tax they would have to pay on a joint income of $60,000. And what we can do is just come back to our tax table, and here it is. And here it says that if you were over $30,000, but not over $60,000, you are going to pay $900 plus 5.8% for every dollar over $30,000. So in our particular case, we are going to pay $900 plus 0.058, that's 5.8%, for every dollar over $30,000, which in our case will be $30,000. And that will give us $2,640. So based upon this particular tax table, or based upon these tax tables, there is no difference if a couple files separately or if a couple files jointly. They will have to pay the exact same tax as you see here. So if this comes up, oh, and yes it will, the answer you want to choose is that it does not matter. And that is all I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.